All right, so I just did a reaction and got ethyl acetate as my product. So I want to show you how to take and analyze the NMR spectrum for this. So I want the proton NMR, so make sure that's selected. And we'll drag the NMR tube over to the flask. And we get the NMR spectrum. And with this, keep in mind, you can zoom in to a peak if you want to look at it more closely. So here we can see we have a nice quartet, and then you can zoom back out, and you can do that for any of the peaks. Now, one thing you'll notice that can be a little bit confusing is there's numbers over these signals. There's not a number over the one at 0 because that's TMS and internal standard, but there's numbers over these three peaks. That's really just telling you signal 1, signal 2, signal 3. Those are not integration values. You need to use the values given. It says it's peak height. That really would be better titled peak area, because this gives you the area of each peak. So you need to use this information to figure out the relative integration numbers. So just so it's a little easier to see, I'll write these integration values above each peak. So what we have for peak 1, the height, which should be the area, is 72.235. For peak 2, it's 99.031. And for peak 3, it's 97.265. So to normalize these, you want to divide them all by the lowest number. So in this case, it's a 72.235. So let's divide them all by that. Okay, so get out your calculator, plug those values in. For this first one, we of course just have 1. For the second one, this comes out to 1.37. And for this third one, we get 1.35. So what you find is we have some integration values that aren't integers, and you can't have 1.37 or 1.35 hydrogen. So what we can do is multiply each of these by a number to get more normalized values. And it's not going to come out perfect in this case, but if you multiply the 1.37 and the 1.35 by 2, we're going to get a value close to 3. So multiply everything by 2. So if we do this, we get an integration for 2 hydrogen. 1.37 times 2 is 2.74, but it's about 3. And likewise, 1.35 times 2 is about 3. And the thing is, you know what structure you're dealing with. We know we have ethyl acetate, which is this. So we know that this structure has 8 hydrogen, and that's what we need in our NMR. So now when we go to assign the peak, now you can do that basically from the chemical shift and splitting. The one that's labeled as number 1 is the quartet, and that's going to be for the CH2 group. The one that is labeled as number 2 right here, that is going to be the singlet for the CH3. And the one, you can't really see it, but it's labeled as number 3, is this CH3. So there's your NMR for the ethyl acetate.